Just a little more terminology here. Let's assume that we have this time a directed graph. So we're orienting edges to go from one vertex to another. And I'll call this vertex U. So we say that the in degree of U, this is usually abbreviated degree minus of U, is equal to the number of edges going into U. So in this case it would be, let's see, looks like there's only one edge going into U. I'll call this vertex V. So there's one edge going from V to U. No other vertices are pointing into U. The in degree is 1. And then we also have something called the out degree of vertex. And this is equal to the number of edges going out of U. It's abbreviated degree plus of U. And as I said, it's number of edges leaving U. So in this case, it would be, let's see, 1, 2, 2. Now, every edge either, every edge leaves some vertex and it enters some other vertex. So if we wanted to count all the edges in the graph, let's let m be the number of edges in the graph. This is going to equal the sum over all vertices in the graph of the in degree of V. So we're just counting the in degree of all the vertices. This is also equal to the sum over all vertices in the graph of the out degree of vertices. So again, if I wanted to count up all the vertices in the graph, there are two ways I could do it. I could either say, okay, I'm just going to count, if I wanted to count all the edges in the graph, I could either count all the edges that are entering vertices. So let's see, U's in degree is 1 plus the in degree of this vertex is 1 plus the in degree of this vertex is 1. The in degree of V is 0. The in degree of this vertex is 2. So we get 1, 3, 5 edges, and you'll see we have 1, 2, 3, 4, 5 edges in the graph. Or count the out degree. So this vertex has out degree 1, 2, plus 2 for U, and the out degree of this vertex is 1. So again, we get 5. Now I'd like to tell you what a subgraph of a graph is. So let me start with a graph, and let's say that it has these edges. It's an undirected graph. So let's call this graph G. It has these vertices, and it has these edges. So to form a subgraph, this is called a subgraph of G. You do the following two-step process. First, select some of the vertices of G. Call these vertices V prime. Okay, so we first select some of the vertices of G. We'll call them V prime. Now, we need to select some edges that were in the original graph among V prime. Okay, so what you get to do is you first get to pick some vertices, and then you look in the original graph and you see, okay, there are some edges here connecting some of these vertices that I've chosen. I'm going to choose some of those edges. And what you're left with is called a subgraph. So let me do an example. So let's say this is V1, V2, V3, V4, V5, and V6. So step 1 says select some of the vertices of G. Okay, I'm going to select, let's see, V1, V4, V5, and V3. This will be my V prime. Okay, so now we have to look at all the edges that were in the original graph among V prime. So let's see, among V1, V4, V5, and V3, well, here's an edge that I might want to choose. Let's see, V5 and V3, yep, here's an edge that I might want to choose. V4 and V5, here's an edge that I might want to choose. And I believe those are all the edges that I can choose from. I can't choose V4 and V6 because V6 is not inside V prime. I can't choose this edge, V1, V2, because V2 is not in V prime. So I'm going to take all of the edges that were in G among V prime. So that means I'm going to choose V1, V3. I'm going to choose V3, V5. I'm going to choose V4, V5. And that leaves me with this graph, V4, V1, V4, V5, V3, and I took all of these edges, so this is my subgraph I'm just drawing a box around it. I tried to draw a box around it. This is the subgraph, which I'll call G prime. So that's how you form a subgraph. You first take some of the vertices, and you denote them V prime. Then you look at some of the edges that were in the original graph, and you pick some of them. So let me pick another subgraph of this graph. I'll choose V1 and V3. Notice that, so that's it, that's my V prime, and I have one edge to choose from. Well, I'm not going to choose it, so I'm just going to be left with this graph. It's a pretty boring graph. It has two vertices and no edges, but it is a subgraph of the original graph. Now I could select all of the vertices in the graph G, and I could select all of their edges if I've selected all the vertices. That's also a subgraph of G. So G is a subgraph of G. Now often it's said that when, so after forming V prime, if you select all the edges that were in G, then that's an induced subgraph. So I'll just write induced subgraph. So that's an induced subgraph. So for example, this graph here, I chose V1, V3, V5, V4, and then I kept all the edges from the original graph. So this is the induced subgraph of V1, V3, V5, and V4. This subgraph here, V1 and V3, it is not an induced subgraph, because though I did take V1 and V3, I did not take the edge that I could have taken. So when you take some collection of vertices from G and you take all their edges that were in the original graph, you get the induced subgraph on those vertices. When you take some vertices and you don't take all the edges, it's a subgraph, but it's not referred to as the induced subgraph. And finally, I want to tell you about one class of graphs that we should be aware of. They're called complete graphs. And a complete graph is when you choose all the edges that you possibly can given a set of vertices. So, for example, K1, and they're labeled capital K. So K1 is just the graph with one vertex. I can't take any edges. So this is the complete graph on one vertex. There are no other vertices to connect to. K2, well, I have two vertices. I can take one edge, so I'll take it. K3, I have three vertices. 1, 2, there can be three edges, so I take all of them. K4, well, there can be 1, 2, 3, 4, 5, 6 edges here. So I'm going to take all of them. K5 has 5 vertices and a bunch of edges. So I'm going to take all of them. So in the complete graph, you have some, if I have Kn, that means there are n vertices, and I've chosen every single edge that could be present among those n vertices. Those are called the complete graphs.